Hi George. So I'll have a look at this question for you, which is 197 on page 129, and hopefully you'll get the gist of what I'm talking about. So the sequence part of the table that I'm filling out is just the numbers from above. So negative 2, 6, 13, 22, 33, and 46. Okay, the first difference is just talking about the difference between each term. So the difference between negative 2 and 1, that's 3. The difference between 1 and 6 is 5. The difference between 6 and 13 is 7. 13 and 22 is 9. 22 and 33 is 11. And 33 and 46 is 13. So you'll notice that all the first differences are different. So what we'll say here is since first difference is different, we can say this pattern is not linear. It's not linear. Okay, so that's our first step there to see whether it's linear or not. Okay, now let's look at our second difference and see what that tells us. So the second difference between 3 and 5 is 2. The difference between 5 and 7 is also 2. The difference between 7 and 9 is 2. 9 and 11 is 2. And 11 and 13 is 2. So our second difference is the same. So that means we've got a quadratic pattern. So we can say since second difference is the same, then it must be a quadratic pattern. A quadratic pattern. Okay, so now I've got to set about working out what this quadratic pattern is. So a quadratic pattern looks like this. T for the term of the sequence is equal to a times n squared plus b times n plus c. That's just the general form of any quadratic equation. We're going to have to find out what a is, what b is, and what c is. And then we can put in anything for n to work out what a particular term of any sequence is. Okay. Now if we look at the first sequence here, n equals 1. And so if we put n equals 1 into here, we're going to get 1 squared, which is 1. And we've got 1 times a. And 1 times a is just a. 1 times b, that's just b. So we've got plus b. And c is not timesing anything, so it's just there by itself. So if all of that equals our first term, well, our first term over here we can see is negative 2. So we can write minus 2. Alright, let's look at our second term. So that's where n equals 2. So 2 squared, that's 4. And 4 times a, that's 4a. So we'll write 4a plus. Okay, then we've got b times n. So b times 2, which is 2. So we've got 2b. And then c is by itself again. And that's all equal to our second term of the sequence, which is 1. So I'll put 1 in. Okay, now for our third term of the sequence, so putting 3 in, we're going to get 3 squared, which is 9, so I've got 9a. Putting in 3 here, we've got 3, so we've got 3b. And then c is by itself, so we just leave that. And our third term is 6. Okay, so now I've got a set of things called simultaneous equations. So I'll label the top one capital A, the next one capital B, and the bottom one capital C, just so we can keep track of stuff. And we're going to solve these using a method called elimination. So I'm going to go C minus B, so equation C minus B, and hopefully that will eliminate one of my variables. So 9a minus 4a is 5a. 3b minus 2b is b. C minus C is 0, so don't write anything. And 6 minus 1 is 5. So I've eliminated C. So if we can eliminate C from another equation, that will help us solve this. So for my next equation, I'm going to go equation B minus equation A. So 4a minus a is 3a. 2b minus b is b. and c minus c is 0, so we don't write anything. And 1 minus negative 2, so I'll write that out here, 1 minus negative 2, that's the same as 1 plus 2, because two negatives make a positive, so that's going to be 3, so we're going to have 3 here. So once we've done that, we can subtract these two equations from each other. So that's going to give us 2a, b minus b is nothing, it's just 0, and 5 minus 3 is 2. So now I've got 2a equals 2, so I'll divide both sides by 2, so my 2's cancel on that side, and a equals 2 divided by 2 is 1. So if we just consider what we've done here, we've found a. So now we want to find b, so I'm going to take what a is equal to, and I'm going to put it back into my original equation instead of a. So that means I'm going to write down 3 times 1, which is 3, and then plus b equals 3. So subtract 3 from both sides, so my 3's cancel out, and 3 minus 3 is 0, and so b equals 0. So now I have a and b, so I can put them both back into my original equation. So I'm going to put b into here, and I'm going to put 1 into here instead of a, and we'll write out that top equation again. So, oops, let's change colour here. So that's going to be 1 plus 0, 1 plus 0 plus c equals, if we look at that equation up there, it equals negative 2. Negative 2. So let's subtract 1 from both sides, so 1's are gone. 0 plus c is c, and negative 2 minus 1, so we'll just write that out, negative 2 minus 1, that's going to equal negative 3. Okay, no double negatives here, the negatives are all by themselves. Okay, so c is negative 3. Alright, so let's just relate that back to what we said right at the beginning. So we've got a equals 1, b equals 0, and c equals negative 3. And that was to try and help us find the rule for t equals an squared plus bn plus c. Okay, so a we've worked out as 1. So 1 times n squared is n squared. B is 0. Anything times 0 is 0. So we've got no n term. And c is negative 3, so we've got minus 3. And that is our rule. Okay. Now for that question 197, it's asking us to find the 10th term. So I need to do that too. The 10th term. And so what that means is they want us to put in 10, the number 10, instead of n. So let's do that. So I'm going to write t equals 10 squared instead of n squared. 10 squared is 100. 100 minus 3 is 97. That's our answer. Okay, George, hope that helps. And just email me back if you've got any other questions. Thank you.